there is the urban transformation issue, and of course, the pandemic has effects on the sustainability of the buildings that we are living in. Our speakers will talk about this. In the panels, I listened to some other contractors. So each of the speakers, their star word is sustainability. And the speakers I have listened to say that, yes, it is not only about making profit. We have to look at the new normal, the climate crisis that will be made into part of our business plan. And I hope that these are not just words. And of course, some things has to change in this regard. And I don't want to take much of your time. I'd like to invite the first speaker, TurkeyHAVAK General Director, Managing Director, Ahmet Göks. I'd like to give you information about this before I'd like to introduce him. He's a graduate of 1979 mechanical engineering of Yıldız Technical University. He worked in the professional sector for 10 years. In 1988, he established HAVAK Corporation for air quality, and he established General Winter HAVAK Corporation if there is any mistakes. So he's been working in both firms actively with Professor Dr. Hikmet Karakoç. He's the co-author of the book, The Humidity Technique, and he is a co-climate assembly member in TOBB, and he's working in many NGOs actively. Ahmet Bey, welcome. Thank you, Yasemin. Thank you very much for your very nice words and introduction. You made a summary of my CV, very nice. If you allow me, I'll share, I start my presentation. I think you can see it right now. Not right now. Could you please make it full screen? We have not yet seen. This is not a problem. If you can share it. Please, we will ask from Gamze Hanım. The friends in technical team can help. You can continue this way, Ahmet Bey. Can we go, can we proceed with the slide? The floor is yours, sir. First and foremost, there is a very nice weather in Istanbul, a sunny weather. And I'd like to thank all the participants participating into this conference. I'd like to salute you with respect. We'll talk about zero energy buildings and pandemic. As Yasemin pointed out, I've been in the sector for 43 years. However, the last 2 years went for the pandemic and the ventilation relationship. We are working on this regard, and we are also making research about this. COVID-19 entered into our lives. Gamze, please proceed. Sorry for the technical inconvenience. COVID-19, after it entered in the beginning of 2020s, unfortunately, the price was very high. We know that for more than 4,000 people died because of this pandemic, but there were some very good lessons about this. The hygiene, the cleaning, the unnecessary contacts are prevented, how to act while coughing and sneezing, and for social distance with people, and we can decrease the pandemic rates through and contamination rates through that. So it's about having the cover of the closets, and the closets, when they flushed, it was forgotten to close the cover. What happened? Barker and Jones in 2005, in their experiments that they conducted, they saw that it is about Clostridium difficile microbe. After flushing 12 times at 12 closets, there are still, this microbe can be contaminated into air. And when you flush it after 24 times, even it is, the spores are within the water. And this is something that we know, but this was something we know, but we had neglected it, but we can understand how important it is once again. And this is something that we learned regarding hygiene conditions regarding COVID. The importance of ventilation. Why is it important? After the COVID-19 virus in March 2020, the pandemic was announced by WHO. In the first months, WHO and CDC, Center for Disease Control, of which HQ is in the States. So they said that there is air contamination is possible, but the real contamination is through contact. Some international organizations and climate technical condition, they said that this virus is contaminated in the air. Following that, WHO and CDC said that the air contamination is the most important contamination. Therefore, it was accepted that this is an indoor area disease, so that in indoor areas it is contaminated to people and it is more disseminated, prevalent. This was accepted by all the world. And in such conditions in the buildings, the ventilation and climatization should be overviewed. And there were some measures to be taken. The measures to be taken increased the energy use consumers, and it caused zero building to use additional energy even for a short period of time. And when we say the ventilation and climatization systems, when the buildings were designed, the pandemic wasn't discussed, and in the fresh air consumption, for energy, keeping the energy level in the low, for people's energy demand, there is a 30 to 40% of fresh air was designed, and the flowing air is used with cooling and heating. What we have is the the carbon dioxide shouldn't be taken upwards of the limits, and the carbon dioxide intensity increases 15% of the disease contamination. So carbon dioxide concentration is important. For example, in the classes in the schools where there is a huge accumulation of carbon dioxide, the carbon dioxide concentration was trying to be lowered. Of course, the schools and the ventilation will be explained by Esma. Regarding in the UK, the institution, there is a building bulletin in letters, as you can see on the screen. And in this graphic, you can see the maximum carbon dioxide limits which are allowed. And if the natural ventilation isn't there, there should be, on average, during the day, the carbon dioxide concentration should be 1 1500 ppm, and if it is over that, it should be only for 20 minutes. It can be 2000 ppm, and it should be diluted again. And if there's a mechanical ventilation, it is 1000 ppm, and for more than not for 20 minutes, there is a 2000 ppm. The carbon dioxide concentration can be taken under a certain level, and we can continue. In ventilation and climatization networks, when we look at the pandemic, after the pandemic is there, it's the pandemic scenario, so and implementation of pandemic scenarios was put on the agenda. The first one is the prevention in the virus contamination, increasing the 100% fresh air, and also regulating the air direction. And if there is going to be cycled air, it has to be filtered. However, when we are in 100% fresh air, the heating and cooling capacities will not be enough, and therefore this capacities should be increased, and this means more energy consumption. And if we cannot have it, we can use the recycled air, and this cycled air should be gone through the HEPA filters, so that it can, we can catch the viruses there. When we use HEPA filters, of course, there is the additional resistance, and the current fans cannot cover that. It's about increasing the power of a fan, or additional fan could be included. So that it requires an additional energy consumption, and if it is not possible to have the additional fan, or make the fan bigger, there is the UVC system. It is ultraviolet bulbs, and they will not be calculated when it comes to its resistance. There is no reason to increase the fan, but of course the UVC bulbs, they have also increases the total energy consumption of the system. We talked about HEPA filters. I'd like to give you information regarding that. Can you please proceed with the slide? When we say HEPA filters, and this is 0.3 COVID-19, it's 1 micrometer, and it cannot hold it. However, there is an ASHRAE, a graphic from ASHRAE. HEPA filter shouldn't be thought of like a sieve. We cannot say that it allows a 0.3 or not, or allows or not allows that. With the, of course, there is a diffusion, and to receiving the particles and the viruses can be caught. And in COVID-19, it uses the diffusion way. You can see 0.1 micron and 0.3 micron. You can see the catching collection. Once for 0.1, it is a 99.97. However, if it is 0.2 microns, this is 99.94, and there is a 3 out of 1,000. And of course, in ASHRAE 14, it's more, and for 0.1 micron in 1 nanometers, it's above 99.97 collection efficiency. This is an information I'd like to provide you with. Of course, when you put it into the system, there is the additional resistance. And when we use HEPA filter, we use the ducts and filters. When we look at the calculation there is a the back filter, the climatization and conditioning power plant and energy cost. When we say that 39% from the ducts and the losses in the air ones, and when you consider a back filter, it is 32% is from the filter, and the other one is the other system, and 2.3 to 2 or 3% silencer, the connections, the cooling coils, and the others. So it is about the filter, and the energy is a very large energy in this regard. Therefore, in the selection of filters, the energy efficiency high filters are used, and we can see it is in fact that it's a Göks, we are at like minutes. Could you please wrap up? So I'll go quickly. For the air conditioning networks and installations, so there is room type portable air cooling devices in the classes, in the polyclinics, and it could be used in everywhere. This mobile devices are used. It's the last slide. The global warming, as we decided to sign the Paris Convention, by 2050 the carbon dioxide emission will be decreased, and the carbon dioxide concentration will be taken to 200 ppm, which is the case before the Industrial Revolution. And European Union, in order to realize the commitments within the Paris Convention, and so they say that there is the emissions will be decreased by 55% compared to 1999. And in order there is this Fit for 55 program. They started that program. There's a program with many green deals in many areas. Is something that should be conducted. The strategies are there. And the polluters should pay for that. There is the unlimited carbon regulation, social climate to be formed, and for the low and middle income people, the support will be provided. And also there will be better heating systems should be used, renovation investments should be supported, electrical appliances should be selected with energy efficiency. There are many areas that they are trying to achieve these objectives. These objectives are not easy objectives. With the pandemic, it is even more difficult to attain these objectives because of global warming. The heating demand increases by 2050. So we can say that for air conditioning it will be high, and of course there will be the solar energy will be even more in use. And as a country who signed Paris agreement for heat insulation and other areas, I hope that by 2050 we will achieve all the objectives of the convention, and I hope we will have done something for our country. I hope that the virus will be eliminated very soon, and will we go back to the normal, and we will continue for a better and cleaner world. Thank you very much for your kind attention. Pandemic, without pandemic, but we It will be a live where we listen. We will always remember the lessons from pandemic. And the next speaker has an important title. So I saw, but for the first time, I'm seeing someone called as a sick building doctor, Burak Toraman. He's going to talk about the understanding nature and making optimum use of its power. But beforehand, I'd like to ask what does it mean to be a sick building doctor? What does it mean? Hi, everyone. Good morning, everyone. I'm taking my tea with me. I hope you have your coffee and tea with you. In the last 10 years, while making design along with operation, by spending $1 million, I realized that we are building a very good buildings, but I wasn't aware that they were sick. I worked in a very huge investment company. Everything is so perfect, so much money is spent. However, from the design or from the operation, actually related to the current life, there are certain things. Vice President of GIC company said that you're a sick building doctor. So you take the block measurements, the mechanics and architecture systems, and then you say that the problem is there, and then we start making the savings energy. I wrote it down there somewhere, and before leaving the company. And when we say sick building doctor, I don't know whether it means anything or not, but I received copyright from David, and this says, as a website, as a company, I continue this way. So you go to hospital, they visit the blood test, and I check the architecture, structure, and operation, and I say that this is your disease. So I'd like to, instead of reading a Burak-based series, I wanted him to look at this. He's received mechanical engineer training in Süleyman Demirel University. He worked in private sector, and then with that, he established this company with this title, right? Yeah. So I'll give you the floor for the presentation. I think that it is okay. Hi again. I'd like to thank you for inviting me to Zero Build Turkey, and my friends, my sisters and brothers. So thank you for inviting them over to Zero Build Turkey. And when I listened to the panels of last year, we understood that we are not alone, and we saw that I saw that everyone is trying to contribute. The world is of ours. And of course, I'll we talked about the learned lessons. Sorry, Burak Bey. Can you make your slides full screen? If not, you close it down, and our technical team will just intervene. So I tried it, but I couldn't do it, so I closed it down. Sorry for interrupting you. I'll give you this time loss to you. Can you close your presentation? Our friend's screen is there. It's closed, so please continue. I'll talk about three subjects. voluntary. I'll talk about the greenhouse gases, that the systems that will decrease the greenhouse gases. And it's about making use of the optimum use of the nature and understanding nature. When we start talking about references, so it's about how to make savings. And everyone so everyone said that 7 million, 8 million savings has been achieved last year, and everyone said regarding the questions, it's about understanding the nature and making optimum use of it. But I realized that we overlooked the principle, and in the last 2 years, in the last 2 months, so we had to turn our heads to somewhere else, some other direction. If you don't understand the fundamentals, so whatever you do, you cannot be successful. So there is the owner's project requirement. This is I have to talk about this, but this is the birth of the building comes from that. And 0 point, of course, the owners should have a document, and there are the ones, the sick buildings. And by us, by the designers, it has to be taken into right manner.
When they do not understand, we build a passive house, but it doesn't work. Or we make millions of dollars investment, but it is not so efficient. So we need to understand this issue from the very beginning. Authorities and also operators should understand the issue very well. What is the objective of OPR? All designing, envelope, construction, and it is a document that provides efficiency in all these issues. Unless we have this document, then unless we obtain this owner's project requirement, that means unless we formulate it in the very beginning, no matter which equipment that we use, no matter how we design, it will not be zero energy building. Everyone, all the teams should reach a consensus. Of course, based on design is important, but OPR is important. It's like the key document, as in the case of Bible for Christians or similar other religious documents for all other religious documents, like the Jewish document. So when we knew this, it's this LEED, green, etc. All these training issues are important. Let's be sincere. All project owners and also commissioning and implementation documents are not aware of why do we need. And for example, there is solar panels on the roof, but it is not functioning well because they don't have the definition and they just call it this. So it is certified, but the buildings are still sick. In last 6 months, many firms, and I talked to many project managers, unfortunately, none of them obtained a document of this OPR. They have design documents and the architect directed them very well, but there is no document that shows what the final user, what the end user wants. Last week, I was in another panel and we discussed this issue again. Unfortunately, these projects are completed without having OPR or a commissioning authority. In my last firm, the firm that I was working was trying to get this document, and there are still some companies that are trying to get, but unfortunately, majority of these companies try to issue certificate only. Why do we need this OPR? Yes, As we all know, that's ironic. This is the image. Let's put solar energy panel. Let's establish wind turbines, but we do not question what is the optimum function. There is no specification. There is no authority, commissioning authority, or there is no system that commissions. Yes, we have a few extremely important and esteemed colleagues, but these are not enough. And if it is not operated, if there is no commissioning, all buildings are doomed to be sick. And any investment which is not in harmony with the operation will continue to increase the CO2, because this type of projects can be achieved providing that there is sustainable materials, and all these materials should be in harmony with the construction and with the house. This is the way to achieve the life cycle efficiency. We can paint, for example, buildings, but if we don't have electricity panels, etc., we just paint. And we sometimes say, let's ignore them, let's neglect them, although they still produce CO2. Unfortunately, project engineers, unfortunately, accept and act in this way. For example, and they act by saying that there will be no change in this equipment and it causes extra money and it still produces CO2. So it's like a catastrophe. We are acting all these issues and then we make another investment, but finally we get zero. Okay, is it bad to get zero? Yes, it is. I mean, the score of zero, not zero energy, but the score of zero in this project, yes, it is bad because we need to achieve this efficiency. We have 3 questions. And when we answer these 3 questions, for example, when we answer them, then we can have our roadmap for a better efficiency. And so all these projects should be designed in line with the existing data and existing measurements, and there is need for calibration. For example, we say Istanbul, temperature is there. No, but these sets are fluctuating and all these type of sensors need to be calibrated. But when there is no calibration of these sensors, then there is no accurate data. We need to gather all this data. We need to collect all this data. And since I am collecting accurate data, I include them into the OPR, and then the project manager says that you want this is the maximum temperature, this is the minimum temperature, this is one. And although they may say, well, this is not the figure data of the Chamber of Mechanical Engineer, or this is not the data from the International Meteorological Unit, I say, no, these are the accurate data and use these data. So sometimes even these sensors are not reliable because we know that the temperature, CO2, and also humidity may change according to the buildings. For example, there is a shop mall with 68,000 people, but there is a capacity of 1,000 and there was a leakage, so it is not possible to have it. In order to stop this type of poor conditioning, a poor construction sector, we need this demand control system, and it must be installed to all buildings, and it must measure the existing data and then act according to data, because we know that there has been an increase in electricity bills. So sustainable energy, efficiency must be in line with the building materials. We have flow rate, etc. We have so many important scenarios, and these are the key parameters of savings, but we still need reliable scenarios, and these innovative scenarios can calibrate themselves, and we need to have automation sensors. There are a few companies, but we need to increase the number of these companies. For example, in my last 3 projects, we have native, magnet, international, and we have the 4th generation AM, and we publish them as success stories. When we have this automation and we have these clean air within the building at the maximum level and at 100%. So if we use them, it is important for shopping walls, and it is important for our health now, especially during the COVID-19 period. But when the COVID-19 is over, it will make an important issue. You have last 5 minutes. Yes, thank you. This OPR document, this location MEP needs to be tested and checked. Today, in order to design these healthy buildings in the right way, we know that specifications are not enough. And since people are waiting a hero, and we should not rely on heroes only, we should build houses which produce the least amount of CO2, whether it is a passive house, and if there is only equipment, so we should measure them. My next slide, please. Okay, what should we do with the existing buildings? Yes, we say new buildings. What should we do with the existing buildings? In order to make them more efficient and in order to make them in line with the environment and nature, we can begin with our existing buildings, and we need to improve their conditions from a retrospective work. And then when I went to a gym, the owner of the gym was complaining about the quality, air quality, and I told him that I am in this sector and then I can work for him if he wants. And I didn't ask money, it was free. I just changed the chimney values and we just changed. So we need to talk about all these issues in all places. And there is need for customized projects. And in all these projects, we will discuss an issue that is important for the project, for our part. For example, our mind should be busy, should be occupied with this issue, and we should think about sustainable projects. We have a potential here, and it is in our hands. Of course, the government also should deal with this issue, but this is not the case, and hope that it will be the case in the future. Of course, it is a methodology, but it is not working well. And it also harms the air quality. It is smart, but it is unfortunately a bad example. What should we do? We should stop. We should say stop. Because this is not what we want. Yes, disinfection is important, and we are trying to clean the whole world, and all the engineers, architects are trying to disinfect the world, the whole world. Everyone is doing their best, and we need to increase the awareness and renewable energy and storing rains. These are issues, and also natural lighting. These are the issues that we are discussing. And energy efficiency systems are important for manufacturing stage as well. Unfortunately, manufacturers pay attention to this issue because of the authorities' requirements, but we should act in this way for our world. And we should take it a stage further. And it's not only TS 825. We should think about all these issues with no stop, with no break, because it is not even a sick building, it's a dead building. And the public authorities must be involved in this process. There must be certain incentives, and they should not allow the use of ineffective materials. Yes, that's the end of my presentation. So throughout my presentation, I talked about all projects that require investment, that cost something. Let me share an anecdote with you. I had a long chat with a professor. I tried to reach that professor for 3 months, and then he was an important guy and he was quite busy, and he was saying everything was great. And I asked, what are you doing? And my question was, where did you begin? And then he said, we began with the pre-primary school. And I asked, did you begin with the pre-primary school buildings? No, he said, no, we began with the pre-primary school children to change their mentality. And I contacted him, I visited him, I measured these schools with a special device. And in a school with 13, in a classroom with 13 students, there was this CO2 at 1,000, and it's good. And we have this carbon net zero competition. And we also launched, it turned into design a sustainable energy feature. As an individual, as a citizen of this world, we need to be a person who makes contribution to the future of this world. I think it is not so difficult. We should act. Maybe it is too late for us, but we should focus on children for primary school, secondary school, high school, and university students, because they are open to these issues. We were grown in a capitalist environment. Thanks a lot for providing this opportunity to me. There are questions to you, but I will refer these questions to you later. So there was this emoji with smile. Competition is important. We should embrace life. It's been a long time that I haven't seen my brother Meriç. I had a chance to talk to Esma last week, and I have been talking to Ahmet Bey over via Zoom for last 2 years. Yes, we all miss to come together, meet in person, but let's meet in buildings with lesser CO2 level and with optimum level. Thanks, Burak Bey. Now I would like to move to an important woman engineer, and she's important for all other engineers. She's a role model for us. Esma Sarıaslan. Hello, Esma Hanım. Hello again. She is the co-president of the Association of Women Engineers and Architects. She created her own firm years ago. She is working as a consultant and as a designer in mechanical engineer, and she is the general director of Esma company. She works for hospitals, criminal laboratories, and also buildings for special technology. So these type of buildings require specific details. She worked in the Chamber of Mechanical Engineers as the president of the women branch, and also she is part of several civil society organizations like the Women Entrepreneurs in Ankara. She is married and has 2 sons. Of course, I can prolong this introduction, but your presentation is the main part of this session. So please go ahead. Thank you. I would like to thank everyone for organizing this event, and I would like to thank everyone for joining us today. I will talk about schools today, because engineers who are working in this air conditioning were saying this issue for a long period. So we didn't change our situation, but we realized that this issue is known by larger segments of the society now. Can you see it? Not yet. Can you see it now? Not yet. If you want, our technical team can share it, and then we will move the slide in coordination with you. Let's skip this one. The importance of ventilation in schools. As regards to the education institutes, according to the official data, there are 54,515 public schools and 13,870 private schools, and there are 4 open faculties. In total, there are 68,389 schools, and according to the figures, there are 241,881 students, and also there are more than 1 million teachers, and there are also 273,856 administrative staff or assisting staff. That means more than 18 million students, more than 1 million teachers, and about 300,000 staff. That makes almost 20 million people, and it excludes universities. And according to the Turkish Statistics Institute, the total population is 83,614,000 people. When we include all other relevant sectors, that means 1 out of 4 is in this education sector. That means unless we achieve a healthy school environment, we will not be able to achieve a healthy society at all. The pandemic shows that the indoor quality within closed areas. In this respect, because we were not prepared, and to me, the decision of closing the schools was the right decision, but in this period, we didn't make the required preparations. 17 civil society organizations gathered, and we created this air conditioning requirements for schools, and we created this committee, which includes several disciplines like medical doctors, engineers, etc. And some of our publications, of course, were taken into consideration by ministries. Unfortunately, the Ministry of National Education didn't pay attention to ventilation recommendations. Of course, it requires a budget, so it is not so easy. So these people who constitute 1 out of 4 society, and these teachers, students, because they have this right, and right to health is the key right for them. And following the pandemic, we spent more time within closed areas, and the pollutants became a more current issue for us, especially in schools. When we talk about the schools, there are classrooms with viruses, dust, pollens, and bacteria, and also microorganisms which are alive or dead, and sometimes there's mold and also some other problems, for example, the chemical agents as a result of some experiments, especially during the class CO2, which we produce in the classroom, I mean, teachers and students. And we need to control CO2 level. As a result of this control, we need to improve the air quality in the classroom, because it is important. And the clean air that we need to send to the classroom should be more than the CO2 level. And in classrooms, what we did, for example, the Chamber of Mechanical Engineering in Izmir worked with 3 schools. And according to the experiments, during the first 10 minutes, the CO2 level goes beyond 1000 ppm, and it is problematic for their health, and also it causes certain concentration problems. And in some classrooms, the CO2 level reaches even 5000 ppm in these tests. You can see a graph at the bottom. So if it is 350 and 450, then it is healthy. Until 700, it is acceptable. 1000 means there are some difficulties in coughing, in breathing, and also some smell problems. But if it is 2500, then it creates certain problems. And if it is more than 5000, it has certain problems, lack of oxygen, and also some brain problems, etc. So this high level of CO2 is problematic, and we should prevent it. And ventilation systems are important for our schools. So physical conditions in our schools, because in recent school buildings, one student has almost 1.3, 1.5 square meters. And in a classroom, which is 45 square meters, we have 30 students, and they spend 40 minutes in these classrooms. So the height of the classroom is 3 meters, and when we multiply 45 with 3, it is 135 cubic meter. Given the fact that one student needs 30 cubic meter per hour, let's skip this one. And given the fact that it is 40 minutes, each session is 40 minutes, that means 20 cubic meter, at least 20 cubic meter for each student, and there is one student. That means 620 cubic meter is needed. However, the capacity is 135 cubic meter. That means students have to breathe these poor air 4.6 times during their classroom. And we know that it creates certain problems. Next slide, please. And in order to have this health issue, we need to send clean air to the classrooms in a controlled way, and we need to control the CO2 level, and we need to have this exhaust mechanisms, and it is important for our children's health, and also for academic success. And although we have been talking this issue so long, why don't we take any precaution, any measures? Unfortunately, we do not demand it a lot. So there is need for demand first, and then if we change the perception, then we can change it. And there is no payback issue.
This money is not spent by the managers or owners of the relevant institution. We should request it for our children and also state it in every platform. And that's why I actually value such an event. We are going to create more awareness whenever we discuss these items. These systems, are they really expensive? Let's look at this side of it. Cannot we afford the economic actually spending or costs here? I want to state that economically speaking, the money is taken out of our pocket later on. According to the research in nursery schools or primary schools, children suffer from upper respiratory infection 6 or 8 times. In higher middle or high school institutions, they actually contract 3 upper respiratory infections twice during the spring season and twice in winter and once in spring season. And here, when we look at the costs, we see diagnosis costs, medicine and treatment costs, also insurance costs, including the physician and other health staff. And also you lose your work time as you spend money, as you spend gasoline on your way to the school. Also your children cannot attend the classes, and you maybe seek private lecturer or tutor for that, and they all accumulate in costs. So when economic research or economic assessments are conducted, you see that more than what we spend for ventilation in a year is spent for these costs. That's why engineers and relevant experts should come together and their studies. We should, in order to ensure that our children are healthier, they're more successful, they need to be staying in healthy and hygienic spaces. And we should be spending money on that. We should also do that to ensure we preserve public health. We are going through the pandemic, and here engineers and the doctors and teachers have more responsibility. Even if anything, we can have an air cleaning device for every classroom. They are not actually that expensive, and we should take measures for that. Okay, we talk about heat recovery devices. We talk about carbon dioxide sensor containing aspirator can actually keep fresh air, and we can have a heater, ventilator. These are all the recommendations. We also stated them in writing. None of them has been done. Are they going to be done over time? I don't know, but we will continue to explain so that we do not have increased pandemic spread. Also, when there was this flights, when there was this aircraft crash, we will have a headline. Now we see people dying full of aircrafts, but we accept it as normal. Hopefully, I did not have plenty of delay. No problem. Thank you very much for your presentation. Well, Ms. Esma, maybe private sector, NGOs, and public authorities may come together so that they can start a social responsibility campaign about filters, like one filter for every classroom. Well, we have air cleaning devices. The industry has done certain nice, actually, researches. There's this fair next week. I think you will be able to see them. They are not causing huge costs. Even the parents can come together and buy that, and that's not their responsibility. I definitely do not accept that. I think the administrators should take measures and do it immediately. Okay, thank you very much. Now, our next speaker is the fourth speaker of the day, Mr. Meriç Sapçı. He is the owner of the METTA Engineering and Consultancy Company. He has an experience of 29 years in the construction industry. Hi, Mr. Meriç. Hi, Ms. Yasemin. I would like to greet all the participants respectfully. I would like to share some information. He has been employed in aircraft, shopping malls, office buildings, hotel, and congress centers as part of the planning stage and project planning stage. And he also took part in mechanical engineering projects for the coordination of internal spaces and other spaces. Mr. Sapçı has 3D, you have 3D models, and there's this IEM program model created by you. You can kindly actually share information about that. You have the floor now. Hi, Ms. Yasemin. My name is Meriç Sapçı, not Sapçı. I'm terribly sorry. Well, we are mechanical engineers, but we see engineers working, we are also engineers working as specialists or expert engineers in the construction area. We should actually focus on this side, as we have an architectural engineering role. Also, I want to emphasize that there is no specific training for that in our country. Actually, outside Turkey, we see it on architectural curriculums, but there's a lack of emphasis for this in Turkey. No education policies were developed accordingly. Hopefully, we are going to have such specialists in Turkey. Our colleagues could not maybe achieve, but I will also give it a go. I think you cannot see my slide either, right? I couldn't. So I will ask you to show my presentation. I will tell you about the impact of COVID-19 global pandemic on the building ventilation systems. Actually, we should ask the question of whether our buildings are safe for our health. And that question provides an answer about our awareness, because it has been almost 18 months now since we started fighting the pandemic, and we identified over 219 million cases, whereas we see over 4.5 million of deaths. And COVID-19 global pandemic is shaped by SARS-CoV-2 virus. The virus is known to be actually transmitted through air and aerosol infection in short distance or surface contact. Also are the causes of it. Then it was stated that it can, CDC, ECDC also stated that the most dominant transmit route was air. Therefore, as people living in enclosed areas, we share places like houses, workplaces, and schools. Let's move to the next slide, please. And here, we spend like 80% of our daily life in indoor areas. And we know from EPA in the United States, from the Air Pollution Association data, that our indoor areas are more polluted, twice or 5 times more polluted than our outdoor areas. I had a slide. Can you show it back? I think it is missing in this presentation. Please move to the next. Please move to the previous one. We have contaminants in indoor areas. I mean, we do not see it in the air we exhale, but there are many contaminants. They may originate from outdoor areas like carbon dioxide, carbon monoxide, hydrogen, sulfur dioxide, ozone, radon, or allergens, particles are all taken inside. And then we have contaminants that are already within the indoor areas. The carpets inside, photocopy machines, computers we use, solvents, resins, perfumes, also cigarette smoke. These are the gases released by the organic components into the air. And then we have certain biological contaminants from people, including certain pathogens like CO2 as part of COVID-19. And also we studied airborne microbiological contamination like tuberculosis or Legionnaire disease. Actually, Legionnaire disease results from the installations in buildings. It's part of the pneumonia family. And also there are diseases caused by bacteria like measles and also rubella. Certain viruses might hang in the air. So as we started to live in the buildings for the past 5 decades with heavy use of ventilation systems, we did not encounter much of a biological contamination. But COVID-19, pollution coming with COVID-19 is something unprecedented. Why? Because previously we would see carbon dioxide or other volatile components. We are used to fighting with them. So we have certain standards that we follow as engineers. We use them as we design the buildings. And ASHA standard 62 is the most remarkable one concerning the indoor air quality. And here we look at carbon dioxide and organic volatile components and fight with them. And here comfort, temperature and humidity and human efficiency and oxygen were all ensured as part of this regulation. And we have been successful so far. And we use the minimum fresh air when doing so. In internal air quality, if you have 80% of people being satisfied with the internal air space, then we live in a space with average air quality. That's how we deem it. If you continue to the next slide, we should know that a human being consumes 11,000 liters of air on a daily basis. That's what goes into our lungs. All those contaminations, pollution, microbiological ones, volatile components, etc., go to our lungs. And at the end of 11,000 liters, our health is excessively impacted. We ensured the hygiene of our drinking waters so far. We have ensured that we have ingredients written on the packages of the food we consume and understand whether they are harmful to our health or not. There is such a perception in the world that the air we actually inhale should be as clearly stated as the water coming through our tap. So there's this transformation and increased awareness in the world, and we see that this is going to be the part of the agenda in our country very soon. Let's carry on. Internal air quality has been actually below energy policies for years. When it was first published in 1973, ASHA Standard 64, we know that we experienced an energy or petrol or oil crisis. And in order to consume less energy, we needed buildings with better insulation, with better air tightness natures. And we sort of decreased the fresh air we need. And when you look at the impact of air among mechanical systems, you see that it has a 6% share. I mean, because we take 80% as an average, we always compromised on that. And over the years, let's look at the next graph. Starting with 1973, we looked at whether we can use less fresh air and consume less energy. In 1981, the fresh air was 7.0 liters per second per person, and that actually fell all the way down to 2.4 liters, taking less fresh air, ensuring less circulation, and consuming less energy. As you see, this is 2.4 liters in 1981, and the World Health Organization publishes a report referring to the sick building syndrome in 1984. So if a disease cannot be established with certain diagnosis, and still you see a group of sick people, you actually state that is related to the building structure. And the value is cited to be at least 10 liters and even increased up to 25 liters. But ASHE standard 62 and standard 90.1 have been the guiding principles for less energy consumption, and we follow up on that as engineers. ASHE standard 62 is always lower than standard 90.1. So standard 90.1 deals with energy efficiency, less energy consumption, and lower carbon emission. And actually, it works on measures that will enhance human health. But we see that it has been the case until COVID-19. We should now talk about a paradigm. What is it? A scientifically known approach focuses on energy efficiency and less energy consumption. But that paradigm has shifted with COVID-19. How so? By highlighting the importance of designing buildings with also a focus on human health, not just energy efficiency. As we stated earlier, we spend 80% of our lifetime in indoor areas, and we have the right to inhale fresh air while focusing on global climate change and emission concerns. That's the sort of era we are entering now. By the way, your last 5 minutes, Mr. Speaker. Okay, I'll wrap up, Ms. Yasemin. I would like to refer to these phenomenon as well. Humans are the most valuable pieces of buildings. We spend for design from scratch for $1, and we spend, let's say, $10 for the construction of that building, but lifelong energy and water cost is $100, but actually the amount of health expenditure for people, thousands of people in those buildings, is $1,000. And that's an invisible element. People are the most important elements of buildings, and actually buildings should be designed for them. We always forgot people. We always said energy, 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 but the remaining part matters too. And here, energy will continue to be important moving forward, because we talk about the global change, global warming, and certain disasters, and pandemics are also part of it. And here we talk about personal measures like hygiene, mask, and distance, and also certain administration measures like increased distances, but engineering measures matter as much, as stated by the health organizations around the world, including the World Health Organization. COVID-19 is an indoor disease, and we should ensure those pathogens are away from human beings for their protection. There are practices that can enable that, and actually areas lacking sufficient amount of air are the places for the fastest spread of the disease. So in COVID-19 and post-COVID-19 period, we need a fresh air and purified air. When we mean fresh air, we mean the atmospheric air, but it may not be clean at all times. That's why to ensure that we have germ-free, pathogen-free air, we need to have ventilation, filtration, and disinfection systems. And we can integrate them to the mechanical systems. We have that opportunity, we have that capability. And here, one of the most important issues is to decrease that exposure duration. So we will not encounter an air with virus, and also we will ensure that we decrease the concentration. I do not mean to elaborate on details as it has been explained by my colleagues, but we can say that now we face a paradox after a paradigm. There is this dilemma, and we are actually responsible for resolving that dilemma as engineers. Here, we should align the energy consumption resulting from fresh air production with the lesser carbon emissions releases from our buildings as part of the global climate protection policies. So here in the construction science, we as engineers have an important duty to take public health measures before we see actually the onset of diseases. So we are not just mechanical engineers, but rather engineers with capabilities who can protect public health through necessary measures. Moving forward, the entire globe sees that engineers dealing with the construction activities as part of the construction sites will have more paramount duties as we will be able to resolve lesser carbon emission and public health together with designs, and we should be able to ensure that those solutions are part of our buildings. Thank you very much for your attention. We'd like to thank Mr. Meriç Sapçı very much. Mr. Meriç, then actually we should take the health of the planet and human beings within this same pot with the equation, right? Yes, this is very important, and zero build focus on carbon emission and energy consumption. But then we crashed a wall, COVID-19 wall, when we came to understand that our health matters a lot, and we will ensure that the air we inhale is as healthy as the water we drink. Maybe this will extend our lifetimes as well, as we are heavily impacted. The world is discussing these measures now, but unfortunately, our country hasn't discussed them. Our country and the world has different frequencies, but hopefully we will be able to explain that more moving forward. Thank you very much. There are actually other questions, but I would like to now move on to our next speaker, Dr. Sanem Şener Özbil. Welcome, Ms. Sanem. Thank you very much for joining our event. Before giving the floor to you, I would like to inform our audience Istanbul Technical University Chemical Engineering is her undergraduate studies, and she had her doctoral degree in Miami. and studied at PresidentThe and Boya, and then she also works as a deputy manager of installation division. Have I missed anything? No, thank you very much, Ms. Yasemin. Okay, I leave the floor to you now. All right, our technical guys, technical people, I think, are sharing the presentation. I think we've been going in the right order because my presentation will be like a continuation of what Mr. Meriç presented. Today, I will tell you about the impact of the external heat insulation systems on human health. We can move on. Yes. In late 2019 and early 2010, we saw the onset of COVID-19 pandemic, and we actually got on the train after the announcement of the health minister on March 10. And we started to see new visual and graphics in our lives. We can move on. For example, we started following these tables on a day-to-day basis. I think the number of people following these tables is decreasing now, but I still make sure that I keep track of them. Starting with March last year, we started to be actually confined in our homes, taking our jobs home, taking our children's school home, and we gave actually many messages like stay at home to preserve our health. But we came to realize actually the healthy, whether our houses had any healthy state or not. We learned about the state of health in our homes. Okay, then this begs the question of what is a healthy house? American National Center for Healthy Housing states that these are the houses that are designed, built, maintained, and rehabilitated according to the health of users. And the World Health Organization on the right-hand side refers to internal air or indoor air quality. And we refer to the importance of ventilation in the indoor areas, as well as referring to the pollution. So when you think of the world as a whole, looking at facades, ceilings, windows, you actually see the importance of insulation as shown by many studies. National Center for Healthy Housing also puts forth 7 principles for healthy houses. It says it should be dry, away from humidity and moisture, as these factors impact the building structurally as well as the people living inside. These houses should be clean. It should be clean from the chemical as well as human-related pollution. It should actually be cleaned of the insects, it says, or pests, as it has an adverse impact on our health. It should be safe or secure, it says, structurally speaking, indeed. It should be free of chemicals. For example, for long years, asbestos and other substances were used. So it says that they should not be used, or lead containing paints should not be used, it says, or VOC component-free paints actually should be used inside our homes. There should be good ventilation, and our colleagues have already made their explanations, and it should be maintained according to the last principle. Let's move on. The WHO have many research instances producing statistical data. I compiled a few of them. In Europe, every year, 100,000 deaths or important morbidities result from insufficient residential conditions. Also, 15% of the European population is determined to live in unhealthy buildings. due to leaking roofs and other issues. And actually 20% of the population live in houses which does not protect them against against excessive heat in summer, and 13% lives in homes without enough or adequate heating during winter. We're talking about the European continent, which actually implements important construction-related projects with a focus on climate. And here, with the World Health Organization says that very high or low heats have direct impact on human beings. Here, of course, we talk about efficiency-related gains, social gains, but they should all be evaluated together with the health of the individuals. And we should look at energy efficiency, fuel actually poverty, as well as climate change strategies in combination. That's what the World Health Organization emphasizes. Also, the WHO refers to a temperature range between 18 to 24 as ideal. It depends on the actually the different geographical and climatic conditions of countries. You can reckon it as 22, 24. We can ensure heat balance inside homes, maybe using excessive amount of energy, then and maintaining that air quality and balance becomes the most important issue. And here the most effective and fastest solution appears as external facade insulation, heat insulation. And when you look at the buildings lacking that insulation, actually you see that the internal air quality, heat, and actually humidity constantly change in buildings that lack such insulation. And here I'd like to refer to external thermal insulation systems. Here we talk about the readily available products that are practiced on top of each other. Let's move on to the next slide. Here, what do you have? Actually, you have a paste, and here we paste our heat insulation panel to the facade, and then we have the insulation materials doubles, and then actually a plaster on top, and then we have the cladding lining and also mineral coating. Also, we have other auxiliary materials, and we apply paint on top of them. However, here we have 7 components at minimum. So their quality and cohesion with each other becomes all the more important. In addition to their own qualities or technical certificates, they should also be actually be compliant with each other, determining the lifetime of these applications, and it's an expensive one. As a company, we believe that their lifetime should be as long as the lifetime of the buildings themselves, but their quality should be complemented with their actually compatibility with each other.
This is in the other facet. How does it affect it? What kind of an effect it has on the indoor quality? This is a visual that I'd like to show you. And also, the other facet the elevation is should be from the outside. From heat to cold, there is a transfer of heat temperature, and of course in the winter to keep the air there in order to prevent it that is such an application to be made. We can continue with the next slide. So of course the comfort conditions, we can say that the heat balance and humidity balance, and we're trying to keep it all the time. And in order to continue that, the most important application is the heat insulation. We are living in apartments, so we have huge elevations and facades. And of course, so we can get feedback of the application that we made very quickly. And if we are when we are talking about this, we have to talk about the energy. And here there are two graphics that brings that are the 2018 data. The left-hand side is the Turkey's data. You see that the buildings 30% or 31% responsible for energy consumption, and industry it is at 33%. There is only 3 scores of difference there. And when we look 2019 data, we can say that the building consumption is higher than the industrial consumption. This is a very striking data. When we look at the European countries, there is a 15 score of a difference. However, as I told you throughout the forum, in European countries, there is a decrease of energy consumption, and of course, shrinking that share. There are activities for that. However, there are the activities for decreasing the energy use. The main item gets there, and there is ethics and health. I try to talk about the effects on this. So between the reason there is the condensation because of the outside and inside temperature, and there is a yield and fungus diseases. And as I have seen, as Meriç pointed out, there can be respiratory tract diseases, and with the air quality being bad, there could be other diseases to come. And when you look at the incomes and expenditures, there are huge disadvantages. We can continue. When we look at ethics and its effect on the environment, we can say that on 17 years, I'm sharing the corporate data with you. For 17 years, we are in the heat insulation sector. Last 1 or 2 minutes. And in 17 years, we provided contemporary life to 7.6 million, and there is a saving of 9.6 billion square meters, and the carbon emission saving is at 25.5, and this means that 15% double fold the folded of the Bolu forest. So last but not the least, it is about energy efficiency, and the healthy buildings and their gathering together will make the individuals more advantageous in terms of health and comfort. And of course, when you gather together the work health, and we can say we can understand how important it is. I hope that I'm in Sanayi. We exceeded our time a little bit. So we are closing almost at the close of the session. We don't have time for questions and answers. And of course, I will make a summary of the questions. And I'd like to say this. The first question is to Ahmet Bey from Cem Karabağ. It's about filter, and when we say it is, and how whether there is this system. Yes, Cembe is right. Filter actually within with the resistance in the motor increases the motor resistance, and this is used in motor power calculation, and in the filter, because of this resistance, increases the engine power. And in terms of a filter, the low resistance filters should be there, and of course this will have an positive effect in energy consumption. Has there been such a calculation? I'd like to ask you, for example, in this course, Esma Hanım. The health problems resulting from being in the unhealthy air conditions, is there a total cost of this? We are always talking about in the presentation, you talked about cost. As these are more expensive systems, you said that investors and people avoid it. So as to make a branch markets, make a comparison. Is there any study? I haven't seen such a study yet. I have not. However, we see that this window is opened, and I think that there will be such studies in the classroom. So we have our individual activities. Yes, we worked on how much a cost it will bring about us, about the systems. But when you gather together with the operators, and there is no study of pros and cons about it. Maybe I don't know this. Maybe that study will be conducted in a very near future. But there is one thing. There was a question. I'd like to give you an answer. And the energy efficiency activities, the window and facade systems are discussed. Of course, there are energy efficiency projects. The systems are there. And there will be better features, and we can make it more healthier. And for that, it's about the indoor air quality systems that should be there. When you put this, of course, the energy of the building will not be enough. There is, turnkey engineering systems that should be there. All the systems should be sold with the integrated systems. Thank you very much. One another question. Maybe you can answer the cost of the healthy building and the normal building. What is the percentage of difference? And how much money is taken out from the pocket of the investors compared to other buildings? Yasemin Hanım, when you look at this, in we have there are a lot of unnecessary costs in the construction of a building in order to make the buildings healthy. We are talking about smart engineering solutions right now, and without having an effect in the energy, we see that there are such measures to protect the health, and that there will be an evolution in the standards so that we will not see huge figures. And as Esma pointed out, I'd like to make an addition. Actually, because of the lack of indoor air quality, there is at schools and workplaces, there is the dropout levels, and when you consider these, the health costs that they pay for the undiagnosed diseases, according to the report of, is more than 10 billion USD per year. So we spend a lot of money in this regard, and we have the labor force losses. So we'd like to, the dear participants, and thank you very much for with us together in this Sunday, and thank you very much for your contribution and for your patience. Thank you.